Welcome to WCG Talks Trials, the podcast where we dive deep into the world of clinical research, sharing the latest trends, insights, and best practices from experts across the industry. In each episode of WCG Talks Trials, we'll explore a different area of the clinical trial industry, while featuring a diverse range of clinical research and medical professionals. If you're passionate about advancing clinical research, improving patient outcomes, and driving healthcare forward, then WCG Talks Trials is the right podcast for you. We are so glad you could join us today.
Hey everyone, I'm Silvio Galea, Chief Data and Analytics Officer here at WCG Clinical. Excited to be joined on this episode by my colleague, Kyle Miller, Lead Data Scientist at WCG. We're looking forward to discussing how to incorporate generative AI workflows in clinical research. Before we dive in, quick reminder, subscribe to our podcast, follow us on your favorite listening platform, Apple Podcasts, YouTube, Spotify, so you never miss an episode of WCG Talks Trials. Today's session may be a little bit more technical compared to our others, but it's important as there's a lot of nuance in how to best apply the AI techniques and technologies, especially generative AI, right? We have this conception that it might be magic, you just turn it on and it's ready to go, but realistically, there's a lot more that one has to do behind the scenes. Just because, in the off hours, you're interacting with AI and all of a sudden you feel like this thing is pretty smart. In reality, what it may be doing is just answering based on its understanding of Wikipedia, right? That alone isn't going to be sufficient for it to be able to trigger some workflows, accurately derive answers and insights, or make your job a little bit easier. So we want to talk about how to take the technology and plug it into the day-to-day workflows you have so that we could start gleaning that efficiency in our clinical trials workflows out of and by using generative AI. Kyle, thanks for joining today. Tell us a bit about yourself and your role here at WCG.
Thanks, Silvio. Glad to be here. As a lead data scientist at WCG, I use machine learning and AI to create solutions for clients internal and external to enable them to better leverage data.
Awesome. And I know you're a bit of a musician. I've had the pleasure of working with musicians in my career. I always find there being a great overlap between music and computer science or music and math. Are you able to take anything from your music background and bring it to the day-to-day comp sci AI world?
It's a great question. It definitely has parallels both in practice of training yourself to do certain things, to follow certain patterns. I would say that playing the same piece over and over brings a lot of insight to the rest of your life over things that we practice and ways that you learn how to do things. I think that music fundamentally teaches you that there is an inherent harmony in the universe and there is a way of interacting with the world in harmony with it. There's a lot of disharmonious ways of playing music. Very easy to play a wrong note, but when you play the right note, it's pretty clear and obvious.
It's like when you code the right line or find the right algorithm for the right problem, you find that harmony. Yeah. So today we're talking about generative AI, the latest class of algorithms out there. Let's take a minute, want to talk a little bit about what's behind it, what's the history. How did we get to where we are today before we start talking about how we use it within clinical research?
Yeah, so the story begins with, I would say, like the first calculators that were ever made, like they were made with gears in the early days. Calculators were a way of solving a problem of efficiency. People were obviously able to add numbers beforehand, but what calculators and eventually computers allowed us to do was add numbers very, very quickly and bring efficiency and scale out these computations. And what that lets us do is focus on bigger problems. Now that we don't have to add the numbers together, we can worry about what numbers to add together, basically. And it's pretty much the same story. Every time we make an advancement, once you get to machine learning, you no longer have to optimize the algorithm by hand. It optimizes itself, but you still have to worry about where to apply it. Fast forwarding a little bit, getting to AI and generative AI and these GPTs, it brings the data to you very quickly. I've heard them described as being like a museum, just like you said. An AI, a GPT that doesn't do anything on its own. It can't send emails. It can't access the internet. It can only basically regurgitate Wikipedia articles. There's a lot of power in being able to regurgitate, particularly the most relevant Wikipedia article, but it can't really go anywhere other than where that Wikipedia article is, which is where we are now, introducing tools and creating true agents that can choose what path to take action, send emails, search the internet, access various APIs.
what are some areas where generative AI can be used to help optimize workflows and allow us from the operations perspective to shift our time and focus and attention from data entry to data validation, creating quality, focusing on quality and creating value?
Anytime that we get a new technology, like the example that people often bring up for the internet is that the killer app for the internet is Netflix and being able to stream anything that you want. I don't know that we've discovered, say, the Netflix of AI yet, because we're still developing these tools and they're still growing every day. Eventually they will plateau, but I think what we see right now is that the most powerful and useful ability that these AIs, these GPTs provide us and grant us are the ability to very quickly read information, and that can let you dive deeply into a single document, or you can have 100 GPTs reading 100 different documents and coming together with all those findings. So there's this concept of needle in the haystack. They do these tests where they give it a vast amount of information and have it grab one piece of information. So, whether it's enormous legislative documents where no one person could ever hope to read the entire dense document in any short amount of time, or if there's 1,000 clinical trial protocols that we want to understand in just a few moments. Previously, this was impossible. And now that's a great power that GPT and AI has granted us.
Let's actually talk about how we've used it internally and have seen others use it. Let's talk about the example with the recent ICH E6 R3 GCP guideline that was recently released, and talk a bit about how we're using GPTs and generative AI to be able to help us automatically update some documents to be in line with the latest guidelines.
That is a perfect use case, leveraging this ability to read and understand at scale. These good clinical practice guidelines are dense documents. I myself haven't read them. It would take an enormous amount of time, but that's no problem for GPT to not only be able to read an enormous amount of the document, but also retrieve the most relevant pieces. In application is that we have all of these related documents, like I believe consent forms, training documents, all of these clinical trial templates as well of both of these things are prevalent throughout the industry, and they are all impacted by this ICH change. So for a team of human beings to update these documents, it would take everyone on the team studying and understanding all of the changes specifically that were made to this GCP document, slowly combing through all of these templates, consent forms, training documents, and identifying all of the areas that need to be updated. This would take thousands of man hours. Whereas with GPT, with AI, you simply provide the guidelines as a supplementary piece of information to the target document, which you need to update. And it can, within seconds, identify the key sentences, the key paragraphs that are phrased that need to be updated based on the new guidelines.
There's a lot we need to do in the background to make that happen. Context is important, right? With generative AI, these documents are large, whether it's a small ICH consent form or a broader document. What are some techniques you use to ensure appropriate context and mitigate the risk of it confusing a guideline for a particular piece of information it's commenting on?
So the general technique that's used is called RAG, which is retrieval augmented generation. That's a fancy word for saying grabbing the most relevant pieces of information from a large document and bringing it to the current context window or the current chat that you're having with GPT. And the way that it retrieves the most relevant information uses the very same semantic understanding that GPT has when it talks to you. Without getting too technical, it basically turns each sentence or each paragraph in a very big document into a number or an encoding. And when you provide a new prompt, or in this case, a new document that needs to be updated, each piece of that document is compared to everything in the reference documents. And the pieces that are most similar, that either use the same keywords or they talk about the same things, are going to be identified, and those are brought into the relevant context. And the beautiful thing, the same thing that allows GPT to talk to you and sound intelligent and make correct statements and basically do what seems to be reasoning, there's an argument to be made against that, is what joins the target document to that reference document. If you're stuck thinking about the word level and just doing a simple cosine similarity. Now, when you do Control F in a document and you type in a word and that word doesn't show up, but you know that that piece of information is in there, that's the killer part of GPT, is that these words that are similar or words that mean the same thing are going to be closely associated with one another. The same way that this happens in your brain, where the word red and the word cherry, for like some trivial example, they're going to be sort of close together in your brain. And the very same thing happens with these numeric encodings. So red and cherry will have very similar vectors or embeddings.
So when working with, let's say, an SOP, right, that has to be updated to be in line with ICH E3, V6R3, the engine is going to take this massive document, right? It's like 100 pages. It's going to turn it into these vectors. We'd need a pipeline that would take an SOP, break it down into individual sections, take each one of those sections, whether it's a paragraph or a page, and run it through the full vector space that GPT has to then get back recommendations on what should be changed for the SOP to be in compliance.
You're basically doing a similarity match that you need to update, and your reference documents. This is the ICH change. And the most relevant pieces will be brought together, and then GPT will make a determination where GPT is saying, I think that this paragraph needs to be updated, but it's outdated. And here's the relevant context in the new document. And then as a part of this pipeline, a very important part of this pipeline, which is going to be increasingly important, the more effective and able GPT becomes, is the human in the loop. And that's where they review this judgment and make an assessment with their expertise and accountability as to whether or not this line should be changed, or maybe it doesn't need to be changed. But that search and initial judgment is an amazing ability that GPT enables us to have that solves, thousands, hundreds or thousands of man hours per document, let's say.
Right. One thing you said, which was interesting, was the pipelining and pipelines. I think that's a key pattern to effectively integrate and implement generative AI into clinical trial workflows, right? We have to find that problem or that repetitive task that we're looking to automate. I sometimes say the more boring the opportunity, the better it is for generative AI to be able to tackle. Walk me through another example in the case of transcription, where we've had to transcribe a particular conversation between multiple individuals using generative AI and other machine learning techniques to determine if there was any bias from one side of the conversation.
So another way to think about a pipeline, pipelines apply to in technical situations, and they might sound like a complicated word, but in your everyday life, you yourself have many pipelines. They're really just procedures that you follow when you do something. In the context of utilizing transcriptions and diarization, which means speaker identification, let's call it, AI can be integrated into these pipelines where you have a conversation between speakers. One very trivial and daily example is any meetings that you have at work. Often Copilot is listening. What is Copilot listening to? Well, in the pipeline, you have your source information, your raw data. That's the video and the audio. Those get sent to a model which will transcribe and it will detect speakers. This is using traditional ML, which has been around much longer than GPT. You've seen automatically generated closed captioning in television. So that would be the first step of the pipeline, is to retrieve that transcription and diarization speakers. The next stage, which is brand new, is allowing GPT to read the transcription and make judgments on it. There are practices all over the clinical trial industry where recordings are being made of conversations between patients and doctors, or of trainers and the raters, or again, like meetings between individuals, where it's important to QC these conversations. Another example is anytime that you have a phone call with a representative and they say, like, this phone call may be recorded for quality assurance reasons. It's not feasible to have humans listening to all these recordings. So in practice, normally only a select few of the recordings get listened to, and it's when they were flagged by an outside source. What GPT allows you to do is have basically an individual sitting there listening to every single conversation that is already being recorded for quality assurance reasons, and raise flags on its own for things like fraud, mistakes, anything that you might want to know about the conversation. The same way anything you might want to know about a document, you can ask about these conversations, and they save a lot of time for human review. They give us a focused way of identifying recordings that may be problematic or interesting for the overseer to review. So this solves a problem of previously with like the QC or the quality assurance recordings, you might only listen to 5% or 10% of the recordings as a quality assurance person. But GPT allows you to identify those most meaningful recordings and catch things that you would have missed. So it would increase your affect.
Right. So we can't have people at every conversation that's happening, but to make sure that that training is occurring properly, that interviews are happening without influence. All the transcriptions can be run through a GPT to determine if there's further review warranted, right? Which basically takes that random 5% classification of review and expands it to be maybe the high risk 5% that should be reviewed, ensuring that more outliers are caught. And that can probably be used for other things, not just from a transcription perspective, but also data outliers, right, for data quality, and anything else that's really where the information or the data, quote unquote, is human language.
And that opens up two routes for the owners of this data to take. One, they have more free time because let's say previously you were listening to 5% randomly. Now maybe you only need to listen to 1%. So the amount of work required to oversee this data is diminished. And because you've targeted the most relevant, let's say, records, you are now gaining more awareness of what to look for. You can focus on optimizing these flags, looking for things that you might not have thought to look for because you were too busy listening to the 5%, which was mostly mundane recordings.
Yeah, I mean, it's true. I'm sure a lot of us have come into this industry not because we wanted to do data entry or data review, but really to have a outsized impact on society and give back. And if used appropriately, this tool, this technology, can help us put our time in those activities that are truly valuable in helping things move along. One more opportunity or use case, we talked a bit about transcriptions and highlighting outliers in information, talked about getting hints on how to update documents or local documents based on outside guidelines. What about content and data or information and document digitization? Talk a little bit about some of the things we're doing in that space.
So my favorite example is a project that we're working on called Predictive Trial Intelligence, where we've put together a pipeline that allows us to digitize these protocol documents. They're already kept in digital format, but they're enormous documents. These are like 100 plus pages per document. For a human being to extract relevant information from this would not only take some expertise over how to read these documents and where to look, but a lot of time. And GPT can very quickly extract exactly what you're looking for. So in the case of a protocol document, you might be looking for inclusion-exclusion criteria, phase, all of these attributes of a protocol. But more complex would be a schedule of assessments. What assessments are done, at what frequency. The chart is sort of complicated. And our pipeline marries together an expert system where we have learned from experts how these schedules of assessments are constructed, which has enabled us to guide GPT to effectively read them. And once you have extracted these data, it ceases to be a collection or a repository of unstructured data and becomes a table in a database, which is what you are normally using to run machine learning models. Mm-hmm. So the final output of this pipeline is some data, which is in a perfect format to be learned from in a machine learning way, which is just the first step to understanding some piece of information. Once you have a model that works, that itself teaches you about protocols and the interaction between what they look like and, let's say, their outcomes. So that is the final stage of the pipeline, or the final stage of our application, is trying to take these insights that we are only able to get once we extract all this information and digitize it, tabularize it, and bring that information to clients so that they can better inform the design of their protocols, say.
Yeah, it's a good point you make, Kyle. Generative AI on its own isn't something that's going to do predictive analysis per se. That's more a trait of statistics or machine learning. But generative AI can help generate input that goes into these predictive learning or machine learning models.
That's exactly right. And there's one more expansion I can make over the classification that you stated. GPT, it is extracting lots of information and it's bucketing maybe into different groups in terms of like the phase or the disease that is being studied. But there's another ability that GPT grants us in the context of machine learning, which was previously impossible. And that is that GPT is itself somewhat aware of, for all intents and purposes, the landscape of diseases. It has a surprisingly good grasp on what different diseases are, like what parts of the body they are from, the prevalence within geographies. So when we talk about feature engineering, traditionally it takes a lot of legwork to relevant data to join to your target data and generate a feature. So an example of this is disease prevalence. You would have to have a data set with every single disease clearly labeled, which is impossible to find, and the associated incidence rates across geography. I don't think this table exists anywhere, but GPT has let's call it a 75% coverage of this information across 75% of the diseases. When you take a batch of protocols, GPT can relatively accurately classify the rarity of a disease, and particularly in the context of the geography of the protocol, since trials are only run in specific geographies. And so previously a feature that was impossible to generate, which is the rarity of a disease or the rarity of a patient population with the inclusion and exclusion criteria, becomes like one day of running a GPT prompts on your 10,000 protocols. And suddenly you have assessed like the relative, generally and roughly, the rarity of these different diseases and how difficult it might be to find patients.
Yeah, kind reminder, it's always important. AI is powerful, but it really works best when guided by human intelligence, viewed and overseen by a human in the loop with the appropriate clinical context and regulatory framework, although the information it does bring to the table does help us accelerate those findings and those insights. I think the interesting thing about these pipelines and bringing it all together and standardizing it ties directly into what we're starting to hear about today, what agentic AI is. What's an agentic AI? An AI that is going to not just answer a question, but go out and do a little bit more work on your behalf. And as we're talking about here, it's not just that, you plug and play these AIs and press go and they're going to do it for you. There's a lot of back office, pipelining, engineering, data workflows one has to put in place to ensure that they operate in a more agentic and generic fashion. Really want to thank you for the insight today, Kyle. And before we start tying things up, any closing comments or any thoughts you wanted to add?
No, this has been a really great experience. AI and is one thing that I love that I get to do at work. Going back to what you said in the beginning, it isn't magic, but there is an element of magic to it. It seems almost impossible what it's able to do, not without its constraints and limitations that you have to constantly be aware of, but it is truly amazing. It's been a pleasure. Thank you, Silvio.
Cool. Thank you, Kyle. Thanks for joining us today and sharing your thoughts in this episode of WCG Talks Trials. And also, thank you to our listeners for tuning in. If you've got any questions or would like more information about how WCG can support you in your research, please visit WCGclinical.com. And we hope that you found this episode insightful and that you'll join us in future episodes. Thanks, and bye for now.
Thank you for joining us for this episode of WCG Talks Trials. Don't forget to subscribe to this podcast on your preferred listening platform as we continue to explore different areas of the clinical research industry. As always, we encourage you to join in the conversation. Feel free to reach out to us if you have any questions, comments, or suggestions for future topics you'd like to hear on the show by visiting us at wcgclinical.com/podcast. We're here to serve as a trusted resource as we work to improve lives and accelerate clinical research together.